Welcome to all in this video. My name is Smith Kaur. I'm from Impulse Technology, Delhi, Gurgaon. Today I will demonstrate a carbon nanotube and try to create some stone wells defect into that carbon nanotube. If we are talking about the stone well defect, the stone wells defect rotates two bounded carbon atoms 90 degrees to change their connectivity. It is a crystal defect that occurs in a material such as nanotube and graphene and has significant effect on electronic, chemical, and mechanical property. So, in the steps of going to the creating this structure, we have to go our device studio. As you all can see, this is my device studio user interface. I already saved that project with name CNT. First, we are trying to create the nano tube. So we have to create the nanotube with carbon atom. So we first take the carbon atom from the our local directory. So we'll go to the import option and import local. And there is a 3D materials, as you all know. Now semiconductor, and in you can all see we have to take the carbon one. So this is the carbon atom. Now this is a carbon molecule or a crystal. Now we have to make this crystal into the nanotube. So we have to go on build option, and there is a lot of tools are there. You can use as well. Nanotube. I'll take the nanotube. So this is the nanotube toolbar in which you can give their chiral vectors like n and m value. So I will take this value m 9, and this value will be, I will click on preview. So this is our nanotube and click build option. So our nanotube is now ready. This is the, now we have to expand this nanotube into the some z direction. So I'll go to the, again there is a lot of tools. We use the build option and go to the redefine crystals like this. So in the redefined crystal, I'll take this value. I have to expand this value. So I'll take this value 11. So I'll click on preview. After preview, I will click on build option. So as you all can see, now our carbon nanotube is ready. So now we have to create the stone wells defect into this carbon nanotube. So you can all see, I will select the atom, two molecule into this in middle one. So I will rush that. So as your convenience, you can take this one. I will take this two atom. So here we have to create the stone well defect. So I will select that two atom into the middle one, and after doing this, I will go to the tool option called rotation. You can all see there are a lot of tools are there, as you can use according to your convenience. So I will click on rotate, and this value will be saved along. I will take this value into the rotate along XYZ axis, and this value angle will be 90 will be same. And after doing this, I have to click on plus. So after clicking plus, so I will close it, and now I will click recalculate linker bond. So I'll click on recalculate linker bond. So as you all can see, now see, this is the stone well defect is ready. So see, this is the stone well defect into this carbon nanotube. Now we have to do some analysis of this carbon nanotube with having a which is having a subcarbon stone well defect. So uh, in the process of doing analysis, we have to go on simulator option and click NANODCAL and click SCF calculation. For SCF calculation, I will take the values like this value will be 111, as you all know. This is the SCF calculation for the crystal, in which you can take these values of like electron temperature, electron energy cutoff, exchange correlation. In an exchange correlation, you can take the value like LDA, GGA. I will take the value this one, GGA, PEV96, and for K point sampling, you can choose your values according to your convenience. In iteration control, if you wanted to give some energy, you can do from like check the total energy and give the energy value, and we will go to the basic set, and you can change the arrangement as well, element or atom, and you can also select the Hubbard terms, and you can also select the, if you wanted to give the some collinear and general spin type properties, you can do from here, and also select the arrangement as well. I will click on generate files. As you can all see, the files is generated for this SCF file is generated for this carbon nanotube having the stone wealth defect. So I will click on run. Okay, as you can all see, this is our nanotube job status. So if you wanted to see the status of your calculation, here is a job description, job manager, in which you can see the our calculation is running for nanotube nanodical dot slash scf dot input. And if you wanted to see the status of your calculation here, in the meantime, I will try to get the analysis part. So in the getting the analysis part, I will go on simulator option, click NANODCAL and analyze. Here is a lot of calculations are there in which you can, if you wanted to get the analysis of the density of state, effect potential, total energy, band structure, charge, Hessian, phonon band structure, electron density, potential, trans-channel, eigenstate, full band structure, effective mass, complex band structure, ZT, phonon full band structure, phonon density of state, phonon trans-channel modulus. You can select them. So, so I will select the density of state, effective potential, total energy, band structure, charge Hessian, phone Hessian as well, phonon band structure, electron density, potential, trans-channel, eigenstate, full band structure, effective mass, complex band structure, phonon full band structure, phonon density of state, phonon trans-channel module. You can calculate all these parameters. Like I'll go to the density of state, in which you can select their K point sampling and also their energy range as well. And in effective potential, you can select the value, total energy, band structure, charge, Hessian, I will, and phonon band structure, electron density, potential, trans-channel, eigenstate, full band structure, effective mass, complex band structure, phonon density of state, phonon trans-channel modulus. You can select all the parameters and click generate file. Since this scf.input file is calculated, now we have to run this density of state. Now effective mass and so on, total energy, band structure, charge, Hessian, phonon band structure, as well as electron density. You can run the all the calculation as well. Okay, so according to your convenience, you can calculate these all parameters and see this all calculation in Q form and getting started for running. So now we have to now we have to see the result. So So as you all can see, this is the band structure.xml file. Click right and click show view. Now you can see this is the band structure for this nanotube, and this is the Fermi energy level. And if you wanted to change the view, like middle top band gap, of valence band, bottom of conduction band, you can select from here. If you wanted to see this data into some specific ranges, you can select from here. And now I'll show you the eigenstate. So go to the show view and click now. So this is the eigenstate value, in which this is the effect of eigenstate are shown here. Now click on 2D. When you click 2D, you can see the data like this. And if you wanted to see this value according to your along the X, Y, Z axis like this, and you can also see this data into stereoscope display like this. You can see if you wanted to change the show view, so you can select from here average along Z, Y, and X objective. And also you can click 1D graph. As you can all see, now this is the eigenstate value, energy versus Z. And if you wanted to see in YZ plane, you can see here for XZ plane. So you can see here. Now that method you can you can calculate all the parameters like this. Thank you very much.